So this is the clap switch after I finished soldering it. It's pretty messy using the wires to connect everything, but it works. I have a feedback LED here to see if the circuit responds. The microphone here. I'm planning to stick it into an old shampoo bottle, which will be the case for it. Basically you can turn on and off any appliance. Right now it's connected to an anti-mosquito lamp, which is right here. So here's a demonstration. Double clap, turn on, double clap, turn off. The LED turns on for the duration of the delay I have between each clap. So here, after the first clap, it turns on, and it basically just shows me that the circuit responds and how much time I have for the second clap. Thought it would be useful to see that. Works nicely. Now let's just turn it off. So it doesn't work, right? So let's go over the circuit. Alright, so that's the layout of it. That's how it looks. That's the power circuit. I just took apart a phone charger, so I don't really know what's going on in here. I just know that it gets the mains input and gives me about 8 volts output DC, which is what I use to power my circuit. Control circuit. So this circuit starts with a microphone, of course, which picks up the signal, and it goes and is processed by this op-amp here, which is LM358. It has 2 units inside. One unit amplifies the signal, and the second unit is used as a Schmitt trigger to filter the analog, to give a digital trigger. I have the first knob here to control the gain of the amplifier, and the second knob here is to control the thresholds of the Schmitt trigger. Both of them control this unit here, which is the LM358. Then it goes and continues into 2 555 timers. The first 555 timer is used as a delay circuit, which basically delays the second clap, so that you can turn on the circuit only after the second clap. So the first 555 timer sets the time for that. Has the capacitor and the resistor here to set the timing, and it gets the trigger from the LM358, the Schmitt trigger. Now this 555 timer is a delay for the second 555 timer, which is used to create a rectangular pulse to trigger this flip-flop, JK flip-flop, which is 4027. It requires a digital pulse, so an analog would make a mess with this. So I had to use something stable. So I decided to use a 555 timer to give a steady rectangular pulse. So the first 555 timer holds the second 555 timer off for a brief moment, which is set by a resistor and a capacitor here. I need that because the microphone signal, which I bring from the Schmidt trigger, is fed to both of those timers. But since the second timer needs to trigger the flip-flop, I needed to work only after the second clap, not after the first one. So I have a little delay here that the second timer can't turn on until the second clap, because the first clap turns on the first timer, and it takes time until the capacitor is charged enough so that the reset input of the second 555 timer goes high, and that's where it's able to turn on. But while the capacitor charges, the pulse already passed, so the first clap will not trigger the second timer, which is exactly what I need. However, while the first timer is on, it makes sure that the delay capacitor of the second timer is charged, and thus the second clap, once it comes, it will turn on the second 555 timer, which will give a rectangular pulse which goes to the clock of this JK flip-flop. Both J and K are hold high, so that the flip-flop constantly changing states with every trigger at the clock entrance. So once this second 555 timer gives the pulse, the flip-flop changes state. It drives this relay, which turns on the high voltage appliance. It uses another transistor here, which is a driver, because the flip-flop itself does not have enough current to switch on the relay, so you need a little transistor to do the job. So the output of this flip-flop goes into the base of the transistor, and the transistor turns on the relay through its emitter. What else do I want to say? So I have a flyback diode here, so that the inductive property of the relay does not screw up the circuit on triggering. So this diode is for protection here. And I have a transistor here, which I don't know if I mentioned, but this transistor basically goes into the reset of the second 555 timer, and it turns on only when the delay capacitor is charged. So this is how it works. The first 555 timer charges the delay capacitor, and once it's charged, and it only happens after the first clap has been clapped, so basically when it's charged, only when the first timer is on, the second timer is ready to turn on and switch the circuit. Another thing here is that this capacitor is large, and the resistor too, because I needed quite a large delay so that the first clap will not trigger the second timer. So it charges pretty quickly, pretty slowly, just enough to delay the circuit. However, it also discharges slowly, so what can happen is that you make a first clap and you make a second clap and it turns on your appliance, but then if you clap shortly after, then you will turn it off only with one clap, because this capacitor will still be charged, because it also takes time for it to discharge. So it will not work as a double clap switch for continuous claps. So what I used to solve that problem is I connected this positive terminal of the capacitor to the discharge of the first 555 timer, so that when it turns off, the big delay capacitor is discharged together with this capacitor. So it charges slowly through the RC network and discharges really fast. So that prevents this problem that if you do quick claps, it will turn on and off only with one clap. So this is it. I'm planning to stick it into a shampoo bottle on a plank and hang it on the wall and basically connect a lamp to it to switch on and off the lights remotely with claps, which is pretty fun. I always wanted to do something like that, and just learned enough to be able to do it. So really fun. And perhaps someone can learn from it too.